Welcome to ACS Webinars, bringing you the best and brightest minds in chemistry, live every Thursday at 2 p.m. Eastern. To view our upcoming schedule, please visit acs.org/acswebinars.
Mike Cann is a distinguished professor of chemistry, and he's the co-director of environmental sciences at the University of Scranton. He teaches organic chemistry and environmental chemistry there. He also teaches a course for non-science majors in sustainability. Mike is a force in the field of green chemistry. An awful lot of his focus for at least the last 17 years has been on both green chemistry, and if you think of it as being a much more strategic, the issues of global sustainability. Mike's got a particular passion for education across these areas. He led a team of faculty at Scranton that have infused green chemistry and sustainability into the curriculum. He's also a co-author on several books about green chemistry. He's the editor of a book series, Sustainability Contributions Through Science and Technology. Since 2005, he's been a co-leader of an annual workshop on infusing sustainability across the curriculum at the University of Scranton, and he is a proud member of the ACS Committee on Environmental Improvement. And just before I turn everything over to Mike, what I'd like to do is to give a shout out, first of all, to his classes in organic chemistry and environmental chemistry who are listening, but also I'll give a special shout out to a few people who've come from a long way to visit with us today. We've got Leela and Anil who are in India. We got Yassine from Morocco. Maidan has tuned in from Indonesia. Jean-Claude's here from France. We've got people from South Africa, Mexico, various other countries, and I'd like to thank you all for being here. Mike, the audience is yours. Thank you.
Thank you very much, Joe. It's really a pleasure and an honor to be asked to give a webinar on green chemistry education, and I thank Dave Constable at the Green Chemistry Institute for asking me to do this webinar on green chemistry. So I would like to start out telling you more or less what we want to talk about today, and the first thing is why we need green chemistry. And the short answer, we'll talk more about it, is sustainable development. What is green chemistry? And one of the answers, as we will see, is a tool to foster sustainable development. And then, is green chemistry / sustainability being embraced? And then, where are we with green chemistry education? Where we need to go, at least in my opinion, and how we get there. So without further ado, I'd like to talk to you a little bit about sustainability, because this is where green chemistry is grounded. And as you see here, there was a report called Our Common Future back in 1987, some 25 years ago, and it deals with the issues of economic development and environmental impact and how we meld the two into a paradigm for sustainable development. And you see at the top there the definition from this report: meeting the needs of the present without compromising the ability of future generations to meet their needs. And if we look at this slide, we see something called an environmental impact. And in one way to measure environmental impact, or at least to measure, to look at it, is it's a function of population, affluence, and technology. And frankly, the three of these at this point has led us into the perfect environmental storm. And if we take a look at population, we see that it took us till 1804 to reach 1 billion people on this planet, but within the next 200 years, we were already up to 6 billion, and now we passed 7 billion, on our way to about 9 billion by 2050. And you see down there 1947, and there was less than 2.5 billion people on this planet. And why is 1947 so important? Well, frankly, that was the year I was born, and well, it was important to my mom and dad, but I put it up there because I've seen the population double in the first 40 years of my life. And if I live to 2020, which I hope to do, I will have seen the population on this planet triple. Sorry about that. And then if we look at the middle class. This is a slide from Goldman Sachs, as you see. And you can see right now we have about 1 billion people on this planet basically living the same lifestyle as I do and the rest of the people in the developed countries. And you see that Goldman Sachs predicts by about 2035, 2040, that the population, or excuse me, that the number of people that will join the middle class will bring us up to 4 billion people. Well, frankly, I don't think this is a possibility. Given the consumption waste paradigm of those who live in developed countries, we cannot all live the same lifestyle as I do, right, using so many resources and creating so much waste that we can have 4 billion people live like I do. And certainly, I don't begrudge everybody on this planet living the same way I do. They certainly should be able to, but we've got to figure out a way for this to take place. Now, if we look at sustainability, one of the central questions is, are we exceeding the carrying capacity of the Earth? In other words, are we consuming Mother Nature's capital? You know, before humans came along, Mother Nature had a wonderful cyclic thing going, but we humans are such resource-intensive and waste-producing machines that we are overwhelming Mother Nature at this point. She can't keep up with us. And we'd like to know what you think at this point. We would like to know what you think an ecological footprint is. Joe, can you take this away, please?
Thank you, Mike. So, yes, audience, think about this one for a moment because it's going to frame some of the subsequent discussion. And the choices that we've given you here are, first is an ecological footprint, the tracks of the elusive Yeti in the Himalayas. And maybe on a little more serious note, could it be a measure of the average energy use of each human being? Or, third, a measure of the waste that on average each human being generates? Or might it be the amount of ecological space that is needed to support a human being on this planet? So I'm going to give you just a few seconds to think about this, and please answer. And we'll see what you, the audience, respond with this one. So let me give you just a few seconds here, and I'll count down from 5 now. 5, 4, 3, 2, 1, 0. And so what we see from the audience is that we've got 1% who wanted to cheerfully tell us about the Yeti in the Himalayas. 14% feel that this term would best be used to describe average energy use. 28% feel as though it's best a measure of the waste that each human being generates, and 56% opt for the ecological space needed to support a human being. So back to you now, Mike.
Thanks, Joe. Well, most of you have got that question right. Again, it's the last statement on there. And if we take a look at this next slide, as you see here, there's about 4.5 biologically productive space on this planet for every man, woman, and child. And if we all lived like the same lifestyle that I do, it would be about 18 acres per person. So you see the rub. We all can't live in the same lifestyle that I live, at least the way it's constructed. We have to find a way to lower my ecological footprint. And if you look at the graph, right now we use about 1.5 Earths for total humanity. So the bottom line is our trajectory is taking this up, and up, and we've got to figure out a way to lower our ecological footprint so that we can live within the means of the Earth. If we take a look at this next slide here, this was a statement from Albert Einstein. Again, the unleashed power of the atom has changed everything except our ways of thinking. Thus, we are drifting towards a catastrophe beyond human comparison. And the emphasis is mine here. We shall require a substantially new manner of thinking if mankind is to survive. I think this is a pretty powerful statement. But on this next slide, you'll see that I've modified Einstein's statement. And as you see here in red, our growing ecological footprint significantly exceeds the carrying capacity of the Earth. Thus, we are drifting towards a catastrophe beyond comparison. we shall require substantially a new manner of thinking if mankind is to survive. Now you may think this is overblown, but certainly the types of catastrophes that we're drifting towards at this point, or are surrounding us at this point, would be things like forest depletion, fishery depletion, melting glaciers, melting ice caps, et cetera, and things like ocean acidification. Well, these may not be as dramatic, obviously, as a atomic bomb being detonated or even a nuclear meltdown. I believe that these types of things will end up making significant human hardship if we don't simply get a handle on them. Now, of course, here are some of the issues related to sustainability, at least the environmental issues. And the big question, the central question, of course, is how can chemistry contribute to sustainable development? And the answer, of course, is what is green chemistry? And again, it's the tool to foster sustainable development. If we look at green chemistry, the definition of it from Paul Anastas and John Warner is green chemistry, environmentally benign chemistry, is the design of chemical products and processes that reduce or eliminate the use and generation of hazardous substances. And of course, it does much more than this. Green chemistry seeks to minimize waste, whether it be toxic waste or not. Green chemistry seeks to minimize energy use and minimize resource use, that is, maximize efficiency, and utilize renewable resources if possible. So the bottom line is this green chemistry, this green technology, right, helps to lower our ecological footprint. And wouldn't it be great if actually green technologies like green chemistry could actually take waste, route them back to resources? So if we look at green chemistry, we can think of it as a tool to foster transition to a sustainable society. And you see part of Einstein's quote here, this is substantially new manner of thinking if mankind is to survive. So then the question becomes, is green chemistry and sustainability being embraced? Well, the American Chemical Society is the sponsor of this webinar. And if you see the second statement here is the vision statement, to advance the broader chemistry enterprise and its practitioners for the benefit of Earth and its people. And some of you have heard Bassam Shakasheri, who was the past president of ACS, say this over and over again, emphasizing for the benefit of Earth and its people. So if you look at other things related to the American Chemical Society, the Green Chemistry Institute, who was also sponsoring this webinar, does many things in terms of green chemistry, and particularly they run the Green Chemistry and Engineering Conference, a conference that started back in the 90s and has grown to be one of the premier conferences in green chemistry in the world. And then we have green chemistry roundtables and pharmaceutical formulators and manufacturers. And we're going to mention this again, hoping that we can form a green chemistry roundtable for educators. The education division of ACS is doing many different things related to green chemistry. And I mentioned the fact that they were involved in one of the first green chemistry educational materials development projects back in 1998, along with the Environmental Protection Agency. There are several awards that are given out by ACS, and I invite you to go to these websites to check out their awards. And the same thing with grants. Many journals related that have green chemistry content. The latest, of course, is the ACS Sustainable Chemistry and Engineering Journal, as started in 2012. Many meetings in addition to the Green Chemistry and Engineering Conference. I challenge you to go to any of the national meetings and look for green chemistry content. In addition, you will find ACS as a sustainability website and the Committee on Environmental Improvement. What else related to sustainability in chemistry? I want you to look at this first line here. This is the title of a report commissioned by the American Chemical Society. and it's entitled The Chemistry Enterprise in 2015. This came out in 2005, and the idea of this report was to look at where the chemistry enterprise will be 10 years from now, i.e. 10 years from 2005. And of course, we're almost there. One of their conclusions was, by 2015, the chemistry enterprise will be judged under a new paradigm of sustainability. Sustainability operations will become both economically and ethically essential. You look at some of these other things that related to chemistry. Chemistry Society presidents pledged support for sustainable development. Any of you who've been to ACS national meetings have seen themes of national meetings related to sustainability and resource conservation, et cetera, et cetera. And in 2012, then president of the ACS, Bassam Shakasheri, one of his initiatives, his major initiatives, was to publish a climate science toolkit for chemists. And over at EPA, wonderful things, of course, going on related to the environment at EPA, but in particularly EPA, out of the Office of Pollution Prevention and Toxics. Right? One of their initiatives is the Presidential Green Chemistry Challenge Awards, and we'll have much more to say about this in a minute or two. What about sustainability in chemistry companies? You notice from this survey that there's a tremendous interest in sustainability amongst chemistry companies. Only 12% reported that there is little interest in sustainability. Excuse me. And the question becomes, are our college graduates prepared to enter the workforce of today and tomorrow? And I point out another study, right? This first study that you see here was published in the Harvard Business Review, and it indicates that sustainability is an emerging business megatrend, equivalent to the megatrends of information technology and total quality management, two megatrends that have totally transformed businesses in the past. And again, I point out the two studies that we saw before from ACS and then that survey. So the question is, you know, are our college graduates being prepared to enter the workforce? And so here's the big question. Has there been a revolution in chemistry education concomitant with a burgeoning and critical emphasis on sustainability? Before we answer that question, I want to point out to you that the UN Decade of Education for Sustainable Development, frankly, is almost over. And I have to wonder, what about us academic chemists? Do we realize this sort of thing? Or are we teaching within our silos, right? Do we understand how we have to deal with the rest of the world, the real world, or are we simply so engrossed in what we do in academia that we are not involved in the education for sustainable development? So I'd like to now, we'd like to ask you another question at this point. And Joe, I'm going to let you take this over again.
Thanks again, Mike. And again, audience, so forgive me if this isn't written perfectly, but let's assume that sustainability is not the highest priority for governments and nations around the world. And the question then is, why is it not a higher priority? And of course, we're going to tell you in advance that there is no right answer to this question, but it would be interesting to know, well, so one of these choices here is because the issue is a sham. And so if you truly believe that, for instance, the world has the buffering capacity, that we can just sort of ignore this, then please choose that option. Second choice is because governments are short-sighted. A third is that short-term issues, for instance, of food sustainability or of access to energy are more pressing. And the last choice that we have before us is because sustainability is just too expensive to address. So please choose one of these, and we'll see how the distribution goes. I'll give you a few seconds here. We'll count down from 5, 4, 3, 2, 1, and we'll close the poll. So only 2% of people listening today feel that the issue is a sham. About a quarter, 25% of you actually, choose that governments are short-sighted, and this isn't something they feel they can address because of that. 60% choose the option of because short-term issues are more pressing, and only 13% choose because sustainability is too expensive. And again, Mike, back to you now.
Thank you. Thank you, Joe. Again, so the question before us, has there been a revolution in chemistry education? Has there been a revolution in chemistry education concomitant with a burgeoning and critical emphasis on sustainability? And what I'm going to do today is talk about undergraduate education. For those of you who are hoping to learn about K through 12 education, I ask you to go to Beyond Benign and their website with Amy Cann, John Mortar, and Kate Anderson. They've done a wonderful job with K through 12 education. So if we think about, we asked the question, what have we done since the term green chemistry was coined in 1991? Well, I think the green chemistry education material development started in earnest in 1998. ACS and EPA had a green chemistry educational materials development project. And many supplemental materials have been developed for both lecture and lab. And there is a list of resources that we've developed that you will find on the ACS website associated with this webinar, which I encourage you to go to check those out. And I think the greatest success that we've had in terms of green chemistry education has been actually in lab courses. And I also have, on this slide you see that there's a URL, and I encourage you to go to that to look for some great experiments that have been compiled by Amy Cann at Beyond Benign. Now, we all know that it's difficult to put new materials into our courses, but at least these supplemental materials that have been developed help to lower our energy of activation to put these new things into our courses. Now, there's a couple different approaches, perhaps, to at least the green chemistry lecture, in other words, into the classroom as opposed to the lab. One is to develop a separate course in green chemistry. This would be given at an advanced level with many green chemistry, or with many chemistry prerequisites. And of course, one could have a detailed higher level of discussion of green chemistry in one of these types of courses. And these, of course, would be populated by junior/senior chemistry majors. A second approach has been to blend green chemistry/sustainability throughout the courses in the curriculum, both lecture and lab. And so as we go from general to organic to inorganic, etc., our students see that green chemistry applies to all fields of chemistry. And this allows us to reach a much wider audience. Certainly in Gen Chem we have far greater people than just chemistry majors or biochemistry majors. And this mainstreams green chemistry throughout the curriculum. So what's the best way to do this? Well, I would encourage people to try to do both. And I don't think there's one right answer to that. And by the way, you see at the bottom, toxicology, environmental chemistry, industrial ecology / life cycle assessments. The bottom line is we should be teaching these also in our curriculum, but that's a discussion for another day. Sorry about that. I point to some of the institutions that have green chemistry courses. Terry Collins at Carnegie Mellon is a pioneer in green chemistry, and he actually has an online green chemistry course. And I point you to some of these other schools that have green chemistry courses if in fact you're interested in doing a course in green chemistry. And this is only a partial list of institutions that have green chemistry programs or green chemistry courses. I also point you to these other institutions and other people, and this is only a partial list. I hesitate to put a partial list up here because I know I've left out many people from this list. But if you are interested in green chemistry education examples, I encourage you to get online and find out information about each one of these programs. I particularly want to mention the University of Oregon with Jim Hutchinson, Ken Doxey, Julie Hack, Deborah Exton, etc. They've been doing a wonderful thing with their organic chemistry labs and other things. As a matter of fact, there's a workshop that the University of Oregon has been running since 2000 each summer, and I encourage you to take a look at it. If you look at some of these other institutions and other people, they've done some wonderful things with labs, lectures, etc., etc. Now, what I would like to talk about towards at the end of this webinar is green chemistry in textbooks. And the question is how much and in what format are we seeing green chemistry in mainstream textbooks? Are they boxes within the chapter or at the end of the chapter that we can conveniently ignore because it's not part of the chapter, the mainstream topics? Are they end of the chapter exercises, web materials? Is it a new book with a green chemistry slant? Or ideally, is it infusion within the body of the text? Or are there other ways in which to do it? Well, you see at the top of this, has green chemistry education arrived? And I think green chemistry education will have arrived when we see it in mainstream chemistry textbooks. And in 2007, I decided I would do an informal survey of green chemistry textbooks, right? And these are the results. If you're interested in more information about these results, you can go to the reference at the bottom of the page. But as you see, I looked at 141 different books, different chemistry books. Now, I didn't look at every one of these, but I asked publishers to send me any of the textbooks that they had or give me information on any of the textbooks that they have that had at least some mention of green chemistry. And I found that 33 out of 141, or 23% of these books had at least some mention of green chemistry. And I'll say this, with only about 3 or 4 exceptions, even the books that had something about green chemistry in them, it was really little substance. Mostly simply vignettes or boxes which one can conveniently ignore. So the bottom line is we're not doing a very good job in infusing green chemistry into our textbooks. And I give us a date at this point for that. If you take a look at for sustainability, again, with the exception of 3 or 4 books that I'm aware of, we are doing a horrible job of even mentioning sustainability in our mainstream chemistry textbooks. And if we were to try to find a source of information to infuse green chemistry into books, where would we find it? So in other words, where can we find material? And I believe that the Presidential Green Chemistry Challenge Awards are that particular source. And these are given out annually, right, for applied outstanding examples of green chemistry, and they provide a gold mine of material for green chemistry education. And again, if you teach organic, if you teach biochem, if you teach polymer chem, you will find information about green chemistry related to all of these fields if you check out the Presidential Green Chemistry Challenge Awards. The abstracts of these awards are available online. You see the URL right here. And if you would like a proposal, actually the winning proposals, you can request them from the EPA, and they will provide you with the winning proposals. There are some 80 some odd winning proposals because this program started back in 1996, and about 5 awards are given out each year. If you're interested in some educational examples, you may want to take a look at this. There's a couple volumes on real-world cases in green chemistry. This was sponsored by the American Chemical Society, and there's the URL for that. Mike mentioned that a copy of 2 of these will be given away with this webinar. And I want to tell you a little bit about something that we've done at the University of Scranton in our green chemistry teaching modules. And this, you can see, was done way back in 2000. What we tried to do at the University of Scranton is to take a topic that we currently covered in a particular course, such as general chem, environmental chem, organic chem, whatever, and take that topic and figure out a way to blend green chemistry into that particular topic. And the idea was that as the students went through our curriculum, they would see green chem and gen chem, then organic, then inorganic, biochem, etc., and realize that green chemistry applies to all areas of chemistry. And hopefully by the time they finished our program, they would be thinking about how I can apply green chemistry to both my personal and professional life. And I encourage you perhaps to take a look at these as examples of ways to blend green chemistry into your curriculum. But I would also challenge you to take a look at the Presidential Green Chemistry Challenge Awards and see if you can figure out ways to blend green chemistry into your courses using the Presidential Green Chemistry Challenge Awards. Now, here's what you can do, right? You're going to be our ambassadors for green chemistry. I know when I go to ACS meetings, I go to the publishers' reps and ask them, right, at each of their tables, the publishers' tables, I ask them to see, is there green chemistry in their textbooks? So ask the textbook authors, the publishers, the reps, etc., and be reluctant to use that book if there isn't green chemistry into it. And one of the huge things that I've found is that if I suggest ways to authors of textbooks and how they can infuse green chemistry sustainability, they're actually quite open to that sort of thing. Suppose we get together groups who go after, so to speak, certain text authors and publishers to get them to infuse green chemistry. Develop teams to infuse green chemistry sustainability into textbooks. Figure out how you can do it in your class and then write to these publishers and say, or authors, and tell them how you actually did it. Perhaps we could publish a list, right, of texts that have infused green chemistry. Incorporate green chemistry into the standardized ACS exams. We know oftentimes, or many of us teach to the ACS exams, there should be courses related to green chemistry on that. I would like to see sponsored workshops for authors and publishers on the infusion of green chemistry into the textbook. And we mentioned before, the Green Chemistry Institute has roundtables, for instance, for the pharmaceutical industry. I think we ought to have a roundtable for education. And last here you see the Committee on the Committee on Professional Training. And the Committee on Professional Training, of course, sets the guidelines, right, for ACS-approved programs. And if we look at the 2008 CPD Guidelines, the only thing I can see related to green chemistry is students should conduct themselves responsibly and be aware of the role of chemistry in contemporary societal and global issues. Well, frankly, right now, CPT is developing new guidelines. They're under review. I would ask all of you to urge CPT to require green chemistry and sustainability as part of the curriculum. And you can send your comments and your suggestions to this email address. And frankly, there's an open meeting at the 246th National Meeting. That's not far off, right? It's Sunday, September 8th, from noon to 1:30 at the Indianapolis Marriott Downtown Hotel. I would encourage you to go there and urge CPT to include or to insist upon sustainability and green chemistry as part of the curriculum. This is how we think all chemists should view chemistry. So in other words, everything that we do should be viewed in terms of the lenses, or through the lens of sustainability. We academic chemists have got to get out of our silos and think about the real world, right? And not just teach chemistry the way that's been taught for decades. And my Lord, what is this doing here? Well, this is a picture of my 5 grandchildren. And though I care about all 7 billion people on this planet, these 5 people make it personal for me. I think about how the world will be some 50, 60 years from now when they're my age. Will they be able to live a reasonable life on a planet that has a reasonable environment? And if we go back to the very definition, meeting the needs of the present without compromising the ability of future generations to meet their needs, that was 1987, a quarter century ago. Ronald Reagan was president. Dirty Dancing was in the movies. Michael Jackson's Bad was topping the charts. Gasoline was 89 cents a gallon. The world population was only 5 billion. And things like the World Wide Web, Facebook, Windows, Amazon, and even the birth of our entering freshman classes were in the future. Green chemistry was coined in 1991. So where are we? Where are we at this point in terms of green chemistry education in 2013? The bottom line is we're not very far. We should be way over here on this innovation scale, and we're still back here with the early adopters. We need to move ourselves along and move ourselves along very rapidly. This is not something that's simply a nice thing to do. And as you see here, I've modified Einstein's statement again. And the last part of it reads, we shall require a substantially new manner of teaching if mankind is to survive. And I leave you with the last two statements. Because we understand chemistry, chemists and chemical engineers are morally obligated to green the chemistry that we and others do because we have the know-how. And furthermore, educators and textbook authors and editors have the moral obligation to bring green chemistry to the classroom because we not only have the know-how, but we have the opportunity.
Thank you for watching this presentation. ACS Webinars is provided as a service of the American Chemical Society as your chemistry source for live weekly discussions and presentations that connect you with subject matter experts and global thought leaders concerning today's relevant professional issues in the chemical sciences, management, and business.